Okay, are you able to see my screen, guys? All of you? All good? Okay, so yeah, so functions is a little on the harder side. So I'm perfectly okay. And I also had a look. I think the homework I had assigned was little, I wouldn't say too much, but on the higher side compared to the last couple of weeks, I guess. But that's fine. So before school reopens, you guys have all the time. So you should have at least attempted, given sufficient time for it. Okay, fine. Let's get started with discussing. So since I assigned homeworks from few different chapters, let's go chapter by chapter, right? So let me just go here. Chapter 2, 2A, B, and C. Let's finish the doubts in 2A, B, C first fully. Then we'll go to chapter 5 and so on. Okay. So just to mix it up a little bit, Avya, questions from your side. Your videos off, Avya and Amit.
Yeah. Yes. So sorry. One second. Yeah.
Let's start with chapter 2.
So sort of question from 2A15.
2A15. Okay. All right. So one good thing is, as we did, some other person might also have the 2A15. While I discuss, that'll get cleared as well. So nice. So 2A15. Let me there. Avya, is this the one that I've pasted here?
Yeah.
Okay. Find the defining equation of H inverse of X. Okay. And then X is defined from 4 till infinity. And we'll see why it's defined from 4 to infinity in a bit. Although he could have defined it from minus infinity to infinity, right? So first part, find the defining equation of H inverse. So we'll start with y equal to x minus 4 whole square plus 3. And then the first thing I'll do is I'll swap x and y, right? So I'll say x equal to y minus 4 whole square plus 3. Now I'm attempting to solve for x in terms of...
Sorry. This isn't the one. So this one, it's 14. Sorry, I wrote the wrong number.
Okay. You're good on this one?
Yeah.
Okay, cool. Question 14. Show that. F of x goes to f of x equal to 3x plus 6, h of x equal to this. Yes. Show that f inverse of h inverse of x is h of f whole inverse of x. Okay, so this means we'll have to find each of them separately, right? So let's find, is this popping up here? Let's find each of those inverse, right? So f of x is 3x plus 6. So this is my y, right? So I'll write x equal to 3y plus 6 and solve for y in terms of x minus 6 upon 3. So in other words, f inverse of x is this, x minus 6 upon 3. Agreed so far? Avya?
Yes, sir. Yeah.
You're with me, right? Okay. Now same thing, I'm swapping x and y here. So y equal to 3x. So this is my h inverse of x. Okay, so we have f inverse of x, we have h inverse of x. Let's go to, now he wants h of f whole inverse, right? So let's first find h of f whole inverse. So first h of f would be h of 3x plus 6, right? But h itself is x by 3. So therefore, this is nothing but 3x plus 6 whole divided by 3, which is x plus 2. Okay, so this is your h of x. Sorry, h of f of x. H of f of x. Now, we are supposed to find the inverse of this. We want h for the right-hand side. We want h of f whole inverse of x. So to do that, again, we'll start. So y equal to x plus 2. I'll swap x and y. X equal to y plus 2. Therefore, my resulting y is x minus 2. So this is the right-hand side. Now, we'll have to check if the left-hand side also gives the same thing. So let's do that. So the left-hand side is f inverse of h inverse of x. So f inverse of, what is h inverse of x? 3x. Right? So I'll just put that here. And what is f inverse? F inverse is x minus 6 by 6. Therefore, it's whatever comes in as the input, that's your x, right? So 3x minus 6 upon 3, which is the same x minus 2 that we got earlier. Does it make sense, Avya?
Yes, I got it. Thank you.
Got it, right? Cool. Sumer, question from you on 2A, B, C, anything?
So from 2, I only had one doubt, and it's quite a stupid one, but I don't understand. I didn't understand how to tell if a function's odd, even, or neither. Like question 8.
Oh, okay. All right. Maybe I did not even touch on order even. I can do it. So some of the concepts I realize I had not touched on, but you guys would have known about it earlier or would have read up some briefly on it. Okay, let's discuss. Determine whether the following functions are odd or even or neither. Okay. All right. So yes, I did not cover this in class, right? A function is even. An even function is if I'll just use h just for change, right? If h of minus x is same as h of x, it's called an even function. In other words, it should be the same looking reflected about the y-axis. The h of minus x should be same as h of x. That's what an even function is. Whereas an odd function is if h of minus x is negative of h of x. That's an odd function. So an odd function will look like, so let's say this guy is going like this and like this. So this guy will be the mirror image like this. So you reflect and then reflect it again. You reflect it once and then reflect it again. So h of minus x is minus of h of x. Then that's an odd function. Okay, so let's try each of these, or maybe I'll just try, okay, but let's try this one, right? Determine whether the function is odd or even or neither. So f of x is already given. So what do we want to test? We want to look at f of minus x. So f of minus x is minus 2x, or rather 2 times minus x, which is same as this, minus 3 upon minus x plus 1, which is 2x plus 3 upon x minus 1, right? If I have to rewrite it. Now, if you compare this versus this, it is neither the same as what's given, nor is it negative of what's given. So it's neither odd nor even. Does it make sense? As opposed to, okay, so Sumer, while you're here, between A and C, can you tell me quickly, just by inspection, which is even?
So I think A is just odd, so I guess C is even.
Yeah, it's not like every choice has to have one answer. Yes, A is odd because, yeah, when you swap x, the signage changes, right?
Yeah.
And C is even because whether it's x square or minus x whole square, it's going to be the same thing. You're right. So this is even, this is odd, and the beach wala was neither even nor odd. Okay, cool. Sarah?
I don't have any doubts from 2A, B, or C.
Excellent. Okay, so you have doubts later. Okay, sounds good. So we'll come back to you. Thais?
Same for me.
Thais, your voice is breaking again. Is it just me or? Sarah, can you confirm if you're able to hear Thais well? No, right? So Thais, your voice was breaking, but I heard partially that same with me. Meaning you'll hold your questions for later. Is that right, Thais? Yeah, okay, all right. Okay, sounds good. Keshav, anything from?
Not from 2A to B.
2A to B to C. Moksh, how about you? All good. Who else am I missing? Saravya, Smer. Okay, Amit.
I have done.
Oh, yeah, Dev and Amit. Okay, yeah, fine.
I
Amit,
have no doubts.
no doubts in 2A. Oh, at all. Okay. You've among everything or 2A, B, C?
Yeah, I finished everything.
Excellent. Dev.
So I have 2C9.
2C9.
And also, I don't know how to draw, like without a calculator, a 1 over f of x function. I don't know how to plot the points.
Okay, all right. Reciprocal function. Yes. So 2C9, right? Question 9.
Yeah.
So prove that f of x is an odd function. Prove that mod of f of x is an even function. That one? Is this the one?
Yeah.
Okay. So we just went over the definition of odd and even. So it's very timely question, right? So suppose f of x is odd, g of x is mod of f of x. So f of x is odd, which means f of minus x is minus of f of x because it's given to be an odd function. Now let's come to g. Okay, so g of x is already given, right? I'll repeat it again, no problem. Okay, now g of minus x is what we have to check, is mod of f of minus x, right? Wherever x comes, I'm replacing it with minus x, which is mod of minus of f of x. Because we know that f is odd, right? So we know f is odd, therefore it's minus of f, right? Now this, whether the minus sign sits here or not does not matter, because anyway it's absolute value. Now f of x could be positive, f of x could be negative, doesn't matter. But ultimately the negative sign here does not matter when you take the absolute sign. Do you agree?
Yeah.
Right? So we have arrived at g of minus x is same as g of x, which means we have proved that g of x is even.
Okay.
Does it make sense,
So-
Dave?
So if say g of minus x is equal to g of x, then it's an even function. But say if g of minus x is equal to minus g of x, then it's an odd function.
Correct. That's the definition we went over just a few minutes ago. Yes. So therefore f was even, f was given to be odd here, which is why we said f of minus x was negative of f of x. Yeah, all good, Dave? Okay.
Yes, sir.
And then
So I'm the
you-
reciprocal.
Reciprocal. Yeah. Do you have a specific exam? I could take an example, but if you have some offhand, if you can, one of the questions was there, or I could pick up something.
I remember seeing one, but it was more of a general question.
Okay,
I remember
fine.
seeing one.
Okay, fine. We'll make up one question, no problem at all. So I will say, let's do one simple one, right? So suppose f of x is,
I think 5A question,
read out the question to me, Keshav, if you have the question,
yeah.
or is it very long to read?
No, it's just like they've given a graph and then they've said just plot 1 over F.
Is it
Oh.
5A question 4?
5A question 8.
Question 8.
Oh, even I had doubt in question 4.
Okay. Question 5A question 4 was not it. Okay. 5A question 8 is suppose. Correct. So this is perfect. Let's discuss this. Okay, we'll use this. The graph of f of x is drawn alongside. Draw the graph of f of x and mod of f of x. So that part is easy, right? So mod of f of x, whatever is down
Yeah.
will come up. That part is easy, right? So this portion will just translate up like this, right? And then the what is already up will stay up. So that's easy. Find the intercept of 1 over f of x, right? So what is intercept? Intercept is where it cuts the x-axis, where it cuts the y-axis. So he says find the y-intercept. Sorry, I didn't read the word y. Find the y-intercept. Y-intercept means what in general? Forget about anything. Y-intercept means when x is 0, what is the value? So in other words, he wants find 1 by f of 0, right? When x is 0, what do you get for 1 over f of x? And that's easy, right? So when x is 0, f of x is 1, right? Therefore, 1 over 1 is also 1. So the y-intercept is 1. In other words, 1 over f of x also passes through the point 0, 1, just like f of x did. Right? Are you with me, Dave, so far? Are others also?
Yeah.
Okay. Now, show on the diagram the points that are invariant for the function. So invariant means, again, you could have inferred, invariant means does not change. For example, this is a good point. At 1, right? F of 0 was 1. 1 over f of 0 was also 1, because the reciprocal of 1 is 1. So the other invariant point will be somewhere here, right? Because let's say, I don't know what this point is. We can find the equation of this, but let's assume it's 3.6 or something, right? So f of 3.6 will also be 1. 1 over f of 3.6 will also be 1, because the reciprocal is that, right? And similarly, whenever f of x is -1, reciprocal of -1 is also -1. So these will be the 4 points which are invariants. Okay, Sarah, you agree with me on this one? Reciprocal is same as the number, right? Okay, all right. Now, show on the diagram the points that are invariant. So we have shown on the diagram these 4 points. But I didn't paste the D part well. So let me just paste it again here. Draw the graph of f of x and 1 over f of x on the same set of axes. Okay, fine. He has already drawn f of x. I'll just have to overlay 1 over f of x, right? So this is the part where you had doubt, correct? Now, whenever f of x reaches 0, then you have 1 over f of x is in trouble, because 1 over 0 is not defined. So you have to be careful about whenever f of x reaches 0. So let's draw a vertical line here. Why is this? One sec. I'm sorry, guys. I'll draw a vertical line here. Tools. Draw a line. This is a vertical asymptote. Similarly, at 3, it passes through 0. Therefore, you'll have a vertical asymptote. So there are two vertical asymptotes for reciprocal of f of x. Now, let's see what happens. In the zone from 0 to 1, f of x is gradually decreasing. Still positive, but gradually decreasing. So which means the reciprocal will gradually increase. It'll keep increasing. And then just before 1, right? So for example, f of 0.99 is almost 0. Therefore, this is going to blow up till infinity. So which is why this is a vertical asymptote. Now, slightly to the right of 1, f of 1.01 is slowest negative. And therefore, the reciprocal of that will be a huge negative. So it'll start with minus infinity, right? And then gradually in magnitude, it keeps decreasing, but stays negative because f of x is also negative. And then we know at f of 2 is -1. Therefore, reciprocal of that is also -1. In this band, since the f of x is stable at -1, the reciprocal will be stable at -1. And then between 3 and let's say this point is 3.3, right? So gradually in magnitude, it's decreasing, which means the reciprocal in magnitude will keep increasing and head towards negative infinity because negative number, reciprocal of a negative number. And then same thing, at 3, it's not defined. Sorry, at 3.3, it's not defined. And then slightly after 3.3, this goes to positive infinity for the same reason as before, right? It'll be an asymptote, and then it'll pass through this point and then gradually decrease from here, right? So at 4, f of x was 2. Therefore, reciprocal f of x will be 1/2. And that's it. And that's your sketch. Does it make sense, Dev? Yeah. So the key things to watch out for are whenever f of x is 1 or whenever f of x is -1, that's when the function f and the reciprocal will be colliding. And then the other thing is whenever f of x goes to 0, immediately you have to put a vertical asymptote there because the reciprocal won't be defined at that point. The other thing is, which in this graph is not there, but let's assume the f of x is going further up like this, right? All the way till infinity, something like this. Then gradually gradually the reciprocal of that will go down to 0. So in other words, as f of x proceeds to infinity, the reciprocal will proceed to 0. And then you have to be mindful which side are we talking on the positive side or negative side? Both the reciprocal and the number will have the same signage. So if this is headed towards positive infinity, this will head towards positive 0, meaning it will lie above the x-axis. Right? Does it make sense? Okay. All right. Have you covered all the doubts in 2A, B, or C? Does anyone have anything more?
So how did you figure out that x is equal to 1 and x is equal to that is an asymptote?
How did I figure that at the point x equal to 1 and at the point x equal to 3.3?
It is an asymptote. No, x is equal to 1, the line, how is it an asymptote?
Because f of x is 0, right, at 1.
Yeah.
The black line that he has drawn, I'll just place the black line again. The black line is the f of x, right, that he has drawn.
Yeah.
So f of 1 is given to be 0.
Okay, so if it's 1 over f of 0, then that points that line will be an asymptote.
1 over f of 1, correct, will not be defined. Similarly, 1 over f of 3.3 will not be defined. because f of 1, f of 3.3, they are all 0. Are you with me, Dev? Makes sense, right? Okay. Okay, before we continue on question on chapter 5, any other pending questions from 2A, B, or C? Anyone, guys? Open it up to anyone. Abhya, you're all good. And the rest of the questions in 2. Okay. Okay, let's start with chapter 5. Sarah, you had a question in chapter 5.
Yeah, in 5A, question 9.
5A, question 9. Okay. Oh,
It's
the question right after this, right? Okay. Okay, c by x plus c. X is given to be not equal to minus c, because if it were, then the denominator will be 0. And then c is given to be a positive number. Okay, so all that is fine. And he has drawn a graph also there. On a set of axes like those shown, sketch the graph of y equal to f of x. Clearly show the points of intersection of the axis. Okay, so what are the main points of sketching any graph? So what is the x-intercept? What is the y-intercept? As in, where does it cut the x-axis? Where does it cut the y-axis? Any vertical asymptote? Any horizontal asymptote? Right? These are the 4 things. Let's do one at a time. X-intercept means what? Where does it cut the x-axis? As in, when does the function, let's say y equal to c by x plus c, when does it become 0? Does it ever become 0? No, because the numerator is a constant and that's given to be greater than 0. Therefore, there is no x-intercept at all in this case. Right? Sorry, Sarah, maybe you had a question with part B, but I'm still discussing part A anyway, so it'll be worthwhile. Or your question was in part A or part B, by the way?
even part A, I couldn't solve it completely.
Fine, let's discuss. Okay, good. So y-intercept. Y-intercept is where does it cut the y-axis? So what does y-intercept mean? It means what is f of 0? For any problem, that's what y-intercept means. So f of 0 in this case is c by 0 plus c, which is 1. So the y-intercept is 1, which means the graph passes through 0, 1. Let's say this is 1, passes through 0, 1. Vertical asymptote. Vertical asymptote is whenever the denominator goes to 0. Where does the denominator go to 0 in this case? When x equal to minus c, which I know is not defined, but as it approaches minus c from either side, the denominator is threateningly close to 0, which means the entire expression will be blowing up to positive infinity or negative infinity. So we know that x equal to minus c is the vertical asymptote. So let me draw a vertical line at that point, minus c. Okay, I didn't draw it exactly at minus c, but you guys get it. Okay, all right, that's the vertical asymptote. And then horizontal asymptote. Horizontal asymptote means what? What is the behavior of the function f of x when x approaches positive infinity or x approaches minus infinity, which means for large values way to the right or way to the left, what is the behavior of the function? Okay, so let's look at this expression again. C by x plus c. C is just a number. If you just want to imagine C is 3 or something, that's fine. C is some positive number. So just imagine 3 by x plus 3. I'm just randomly calling out some number 3. He has not given any numerical value. So if x is a million, then practically this expression will fall down to 0, right? 3 by a million plus 3. So this is approaching 0 as x approaches infinity. Do you agree, Sarah? Yes? I'm not able to see you. Sorry, if you're nodding, I'm just unmute and talk, please.
Okay, yeah.
Okay, right? So this is approaching 0, and but still positive, right? Throughout it's going to stay positive, as in as long as x is right. We are talking about a large positive number in the denominator and a positive number in the numerator. Therefore, it's approaching 0 from the positive side. So it's going to approach, like, I'll use a different color, red color. So the horizontal asymptote is the x-axis itself. So x-axis is the horizontal asymptote. If you have to label the horizontal asymptote, the equation of the x-axis, which is nothing but y equal to 0, is the horizontal asymptote. Similarly, here, if I have to label the vertical asymptote, is x equal to a constant as a vertical line, right? The vertical line is x equal to minus c. That's the vertical asymptote. Okay, so we have covered the y-intercept. We established there is no x-intercept. We found out the vertical intercept. We found out the horizontal intercept. Let's see what other clues we can get to complete sketching this graph. Now, when x is slightly to the right of minus c. So again, just imagine -3, for example, just so that you have an understanding. So let's say, I wish I am able to draw this vertical line at, it's bothering me that I'm not drawing it at C. So let me do that. So I think there's some mouse sensitivity there. That's the problem. Okay, sorry guys. I don't think it's any better than before. Okay, just imagine this is passing through C. Now, to the right of -3, right? To the right of -3, which means what? 3 by -2.99 plus 3, which is 3 by 0.01, which is infinity. I mean 300, but in this case, infinity, right? So which means, it's approaching positive infinity here. And similarly, to the left of -3, right? To the left of -3, -3.01, it'll approach minus infinity. So it's going to go like this. Okay, by the way, I didn't complete the horizontal asymptote fully. We did as x tends to infinity, we saw that f of x approaches 0. When x tends to minus infinity, what happens? Same thing. 3 by, let's say, a -1,000,000 plus 3, right? Which is approaching 0 again, but from the negative side, which means it's going to be a small negative value headed towards the negative x-axis. The horizontal asymptote is still y equal to 0 is the horizontal asymptote. Okay, so this completes the graph fully, right? Now, obviously, it does not complete. We have to just fill in the blanks here. So you can fill in them like this and then sketch it. For a sketch, this is good enough. You don't have to be super precise. Sarah, does this look convincing to you? Okay, now that's the A part. B part, on the same axis, sketch 1 by f of x. Okay, so same thing, right? What would we do? Wherever f of x approaches 0, the reciprocal is going to approach infinity. So let's use that. So let me just erase all this extra clutter here. Right. So let me plot the inverse in what color? Let's say green color. Okay. So reciprocal of this is going to be infinity. So somewhere it's going to be infinity somewhere here, right? It's headed towards infinity like this. And let's pretend C is a number which is greater than 1. I mean, he didn't say C is greater than 1. So technically C could be half also. But just so that we understand, let's say C is greater than 1, which means actually see whether it's greater than 1 or less than 1 does not really matter here. What matters is somewhere. What did we say this point was? I'm sorry. What did we say this point was? 0, 1, right? Oh, yeah. So this is 0, 1. So the reciprocal also passes through the same because the value is 1. So f of 0 is 1. Therefore, 1 over f of 0 will also be 1. So this will be the point where the graph will coincide with the reciprocal. So it passes through this. And then, so we know the behavior is going to be something like this. Right? So far out, f of x approaches 0, which means the reciprocal approaches infinity. By the way, you don't even have to do so much. We can just look at the reciprocal function itself, which is nothing but x plus c upon c. And just look at it, that is nothing but x by c plus 1, which means it's going to approach linearly. So 1 by c is just a constant. So it's something like y equal to ax plus b type of thing, right? So what I've drawn is technically, it's going to approach a straight line, right? It's not going to go exponentially. It's going to go approach in a straight line. I'll just, do you understand the last part, Sarah and others? Right? The reciprocal is x by c plus 1, which is nothing but a linear function, right? It looks like a plus b times x, where b is nothing but 1 by c. So a is just a number which is 1. So it approaches, it still goes to infinity, but goes to infinity in a straight line fashion, right? Like this. Does it make sense? Okay. Why even approach infinity? Even at the beginning itself, it's also a straight line. So it's straight away like this. right? It's just a straight line, correct? And then x by c plus 1 will keep coming down. At x equal to minus c, it passes through 0, no surprise, because that's when the reciprocal we saw was going to blow up to infinity. And then it'll pierce through here, right? And then go all the way till here, right? Right? It'll be a slope. The slope of this line, the slope of this line will be 1 by c. Because what is this function? This function is 1 by c times x plus 1. We saw that, right? X by c plus 1. I can write it as 1 by c, which is the slope, times x plus 1. So the y-intercept for this would still be 1, 0, 1, it passes through. The x-intercept will be when x is minus c. When x is minus c, it passes through 0. Does it make sense, Sarah? Fully? Yeah. So I didn't realize it was just a linear function, x plus c by c. So you can just take f of x, reciprocate it, and just start drawing it. Okay, intersection with the axis we covered, right? Minus c, 0, 0, 1. Cool. Next. Let's say, Avya, questions from chapter 5.
Third one from, I think, 5B, question 10.
Okay. All this is clear so far. Whoever is asking the question, my response is not merely to them. If anyone else also has a follow-up question, please ask, guys. Thais, you're all good? Okay. Sumer, all good? Avya, which one was that? 5B, question 9, was it?
So 10.
Question 10. Okay. 2x minus 3 by x, 3x plus 5, that one?
Yes, sir.
Okay. Consider the function, blah, blah, blah. Find the asymptotes. So asymptotes, we know by now. The horizontal asymptote will be as x approaches infinity and x approaches minus infinity. And we know, we have seen from the past that what will matter is the leading coefficient, right? The leading coefficient in both the numerator and denominator is x power 1, x power 1. Both the powers are the same. Therefore, ratio of the two coefficients will be the horizontal asymptote. You're with me, Avya? So the horizontal asymptote
Yes.
will be the horizontal line y equal to 2 by 3. Okay. Ultimately, we'll be sketching it, but so y equal to 2 by 3 is the horizontal asymptote. That's the horizontal asymptote. Vertical asymptote would be when the denominator is threatening to become 0. So 3x plus 5 is 0 when x equal to, so the vertical line x equal to minus 5 by 3 is the vertical asymptote. Okay, discuss the behavior of the graph near the asymptotes. So which means, is it heading towards positive infinity or towards negative infinity with respect to the vertical asymptote? And with respect to horizontal asymptote, you'll have to say, is it approaching 2 by 3 from below or is it approaching 2 by 3 from above? That's the question, right? So we'll come to B. As we sketch part D, we'll be able to discuss part B also. Find the axis intercept of y equal to f of x. Axis intercept is what? Vertical intercept and horizontal intercept. Y intercept and x intercept. Y intercept is when x is 0. So that is 0 minus 3 by 0 plus 5, which is minus 3 by 5. So it passes through the point 0, minus 3 by 5. And on the x-axis, it cuts the x-axis when the y value is 0, which means the numerator is 0, which means 2x minus 3 is 0, which means x is 3 by 2. So it passes through 3 by 2, 0. So these are the two axis intercepts. Now, putting all this together and maybe a little more, let's sketch the graph. So sketching is like an iterative approach, right? It's not like you finish this and then you start sketching completely. So let's do that. So let's draw the x and y axis. I wish I had more space here. Okay. Now, what all do we know? Let's mark all the points that we know. 0, minus 3 by 5. I might not be drawing to scale, but that's fine. 0, minus 3 by 5 is this. 3 by 2, 0 is the x-intercept. And then the vertical asymptote is at x equal to minus 5 by 3. So let me plot a vertical line at -5/3. Okay, so this is the vertical asymptote, and the equation of the vertical asymptote is x equal to -5/3. Okay, and the horizontal asymptote is at y equal to 2/3. So let's put a horizontal line at 2/3. Actually, you're supposed to put asymptotes as dotted lines, but for now I'm just putting as a solid line because in this paper it's a little difficult to draw with. Okay, it's not quite horizontal, but just imagine it's horizontal, guys. Okay, so this is your horizontal asymptote, which is y equal to 2/3. Okay, now let's analyze the behavior, right? So it passes through the vertical intercept and horizontal intercept that we know. Far out towards x equal to infinity, let's analyze. We saw that it's approaching 2/3, but is it approaching from below or is it approaching from above? So the two red dots here are indicating it's approaching from below, right? But let's check that it's consistent with that. For example, suppose this is 2 million. So 2 million minus 3 upon 3 million plus 5, right? So this fraction is definitely less than 2/3, right? Because we are subtracting a little bit from 2 million. We are adding a bit extra to 3 million. So it's definitely less than 2/3, which is why the graph is approaching 2/3 from below, right? And which is consistent with when we connect the two x-intercept and y-intercept, it's heading towards that. Similarly, hopefully this should be consistent when I take it down to -infinity here. Let's check. Around -5/3, slightly to the right of -5/3, right? 3x will be 3x will be slightly less than, okay, sorry. So 3x, I'm looking at 3x plus 5 in the denominator. So 3x plus 5 when x is greater than -5/3. When x is greater than -5/3, this quantity would be positive. Do you agree? 3x plus, okay, maybe I'm not describing it well. I'm looking at the behavior close to the vertical asymptote. So I'm looking at the signage of 3x plus 5. The signage of 3x plus 5 to the right of -5/3. Okay, so -5, the numerically, how much is -5/3? -1.66. Okay, so let's assume x is -1.5 instead of -1.66. So this is -4.5 plus 5, which is 0.5, which is a small positive quantity. So we know overall 3x plus 5 is a small positive quantity, right? And what about the numerator? X is -5/3, and -3 will further bring it down. Therefore, the numerator is negative. So overall, negative upon positive is negative. And we know the denominator is a small positive quantity. Therefore, it's approaching -infinity, as I've shown here. It's approaching -infinity. On the other side of -5/3, the numerator is not going to change much. It'll be the same quantity. The denominator will pass through 0 and change your signage. Let's say it went from -1.5 to -1.7 now. So the denominator will be a minuscule negative quantity, taking the whole fraction to positive infinity here. So it'll approach positive infinity here. And then gradually it will come down. And then far out, let's say this is -infinity, which means we have -2 million, -3 upon -3 million plus 5. So this is in magnitude, this is smaller than, sorry, in magnitude, it's bigger than 2/3, right? Because this is, in other words, I can write it as 2 million plus 3 upon minus of 3 million minus 5. So minus and minus will get cancelled. So it's a little more than 2 million in the numerator. It's a little less than 3 million in the denominator, which means net it's going to be more than 2/3, which is why it'll approach this horizontal asymptote from the higher side. Does it make sense fully? Avya? Completely okay on this?
Yes, you got it.
Cool. So, and as part of this sketching, we have also answered part B, the behavior of the graph near the asymptote. Part E, describe the transformations which transform 1 by x to f of x. This is a good one. Let's discuss this. Okay. Describe the transformations. Okay. All right. Let's. Okay. The first 4 parts are all clear, right? First 4 parts are all clear. Okay. So I'll just write down the equation 2x minus 3 by 3x plus 5. We want the transformations which will lead from 1 by x to this. I'll write out 2x minus 3 by 3x plus 5. So 2x minus 3 upon 3x plus 5. Okay, so let's multiple ways to do this. Let's divide it first and see what we get. So by 3x plus 5. So I have 2 by 3 here, right? So it's 3x. And then how much is this? 10 by 3, I guess. If I do some silly mistake, please catch me, guys. 10 by, sorry, this is 2x. 2 by 3 times 3 is 2x. And then plus 10 by 3. 2x plus 10 by 3. So when I subtract, what do I get? Minus, help me, guys, minus 19 by 3, I guess. Minus 19 by 3. Okay. So net, the quotient is 2 by 3. And the remainder is minus 19 by 3. Minus 19 by 3 upon 3x plus 5. Okay. All right. So 2 by 3 is just a number. Minus 19 by 3 is also a number. So first, let me illustrate it as if these are simpler numbers, right? For example, had it been just, okay, fine, a plus b by 3x plus 5. Okay. I mean, 2 by 3 and minus 19 by 3 is just simple numbers, right? So we'll come back to it. So now a plus b by 3x plus 5. I've just done the division here. I'll just erase this, make space. Now, so from 1 by x, I have to head towards this expression. So how can I, so first I can do 1 by x as 1 by x plus 5. By doing what transformation? That is shifting left by 5, because every x has been replaced with x plus 5. So I'm not going to, okay, fine, let me just write shift left by 5. And then now I can do 1 by 3x plus 5. How can I do that? Now every x has been replaced with 3x, which means the graph has shrunk. So it's a horizontal shrink, right? Horizontal stretch by a factor of 1 by 3. Right? Are you guys with me? F of x, in other words, let's say, okay, so I'll just write f of x has become f of x plus 5 in the first step, right? In the first step. In the second step, I'll replace g of x has become g of 3x. Okay, and even this f I want to, so that you're not confused with the original function f, right? So h of x has become h of x plus 5. G of x has become g of 3x in the next step, which is horizontal stretch by a factor of 1 by 3, technically a shrink, right? And now I want to multiply it by minus 19 by 3 or b, right? So I can do it in 2 steps. I'll multiply it by 19 by 3 by vertical stretch by 19 by 3, right? So that is, I'll just call the j of x has become 19 by 3 times j of x, which is just a vertical stretch by a scale factor of 19 by 3. And now I can just put a negative sign around this by saying it's just a reflection, vertical reflection. So in other words, some k of x has become minus of k of x, which is just a vertical reflection around the x-axis. And now the last part is I'm adding 2 by 3. to it. So let's say g of x has become j of x plus 2 by 3. So it's a vertical translation or shift up by 2 by 3. Does it make sense, Avya? Right?
Yes, sir. Gaurav.
And we know that this is not a unique way of transforming. I can completely take another path, and I urge you guys to try it out later. So for example, from 1 by x, I could have straight away gone to 1 by 3x, right? And even this 1 by 3, I can view it in two different ways. Either I can view it as x is getting replaced with 1 by x is getting replaced with 3x, or I can view it as 1 by x is getting multiplied by 1 by 3, which means, so if I view it in this angle, it's a horizontal shrink by 3, or rather horizontal stretch by factor of 1 by 3, right? Whereas here, if I look at it, so vertically, I'm just stretching it by 1 by 3. So horizontal stretch by 1 by 3 is actually shrinking it by a factor of 3, or I can view it as a vertical stretch by 1 by 3 as well. Does it make sense? Both approaches make sense? Yeah. Sumer, you're with me completely on this?
Yes, sir.
Okay. So that was part E. Part F, describe the transformations which transform f of x into y equal to 1 by x. That's retracing the path, right? So can I leave that to you, Avya, later? Part F should be exactly the reverse, right?
Yes, sir.
All of you should be fine on that. Okay, all right. Sumer, questions on chapter 5?
So I just had one question.
Yes,
It's a very basic question in 5.
sure, no problem at all. Yeah.
But like because of this, I wasn't able to solve a lot of the tougher ones. It was like basically for a quadratic or a cubic.
Yeah.
It gives you a transformation by a certain vector. How do you do that? Like what do you change in the equation?
Okay, tell me a question number, please. If you have one.
5a part 3.
5a part 3. Question 3? Oh, okay. All right. Okay, this is getting, oh yeah, someone else also, I think Keshav also asked me something very similar. Let's discuss this, right? In fact, you had put a question on the group, maybe it came a little late. But the vector 1, minus 2 means it's shifting right by 1 and shifting down by 2, right? That's what 1, minus 2 mean, right? Vector wise, it's x direction and y direction first. So shifting right by 1 and shifting down by 2, okay? Now it's easy, right? Shifting right by 1 means what? Shifting right by 1 is f of x becomes f of x minus 1. So the first step would be every x gets replaced with x minus 1. That takes care of shifting right by 1. Okay. And then shifting down by 2 is entire expression shifted down by 2. So minus 2. As simple as that. Does it make sense, Sumer? Yeah. After this is just a question of expanding this and simplifying it in this form. So that I think anyone can complete it, right? You're okay on that, Sumer?
Yes, sir.
Okay, and that, yeah. Sure.
Yeah.
No, I understand this. It was not discussed in class what the vector because we have not done vectors really. So I did expect some of these questions where you have not seen these conventions.
So I have a doubt. 5a question 4.
Okay, sure. Question, the one right after this again, right? The one immediately
Yeah, the
after
one
this.
right after this question. Question.
Okay, so the graph of f of x is blah, blah, blah. It's tangent at x equal to a and cuts the axis at x equal to b. Okay, so as drawn in the picture, there's no surprise. Now, what is this? C is less than b minus a. Okay, so again, I'd like to think some numerical value so that it's easy for me to understand. So I said this is 2 and this is 5 or something, right? Right now he's saying C is less than 5 minus 2, which means C is less than 3, which means the C is smaller than the gap between A and B. That's what it means, right? C is less than the gap between B and D. Okay, all right. Now what? Sketch the graph of f of x minus c. X minus c means what? Shift right by c. Or in other words, shift right by c and shift right by a quantity which is less than the gap between B minus C, which means the graph will be something like this, right? So it will get shifted to the right, but not too right, right? And then it'll come like this. And that's it, right? So this, in fact, maybe that's one of the next question. Indicate the x-intercept of this. So now this A has moved right by C. So the new place where it graces through the x-axis has become A plus C. And the place where it initially cut was B, now that has become B plus C. So this is B plus C comma 0. So this point is B plus C comma 0. So the x-intercept is now A plus C where it's tangential and B plus C where it's cutting. Make sense, Dev?
Yes, sir.
Okay. All right. Thais, you had questions on chapter 5. If your audio is better now.
You answered all the questions I had.
Okay, as part of other people asking those questions. Okay, sounds good. Wonderful. Anything else did I miss in chapter 2 or chapter 5, Thais? For you, all okay so far? Okay. Sarah, chapter 5.
Yeah, 5C, question 2C.
5C, question 2C. Okay. Okay, this is the one, right, Sarah? Yeah. Use the graph to determine the coordinates of the turning point. Okay. Equation of the vertical asymptote, equation of the horizontal asymptote, and the x-intercept. Okay. So turning point is fairly clear. I mean, he has drawn it reasonably to scale. So this is -2, right? The turning point is -2.
So I think that is minus to 1.8. No, like I was thinking between 1.7 and 1.8.
That's fine. No, that's fine. Yeah. So this is 1. Yeah, and he has, I mean, it's the graph paper is here, like not very, very clear. But yeah, 1.8, hopefully when they give such a question, it should be much clearer. But yes, let's say my 1.8 for now. Equation of the vertical asymptote. The vertical asymptote is happening where it's happening here. So the vertical asymptote is the y-axis itself. So the equation of the y-axis is x equal to 0. So x equal to 0 is the only vertical asymptote. Equation of the horizontal asymptote. Oh yeah, I know you said 2C, but I'll quickly go through the earlier parts. Horizontal asymptote is y equal to 2, right? It's horizontal asymptote. X-intercepts, very clear. Whatever these coordinates are, can look from the graph. Okay. Graph the function f of g of x equal to x plus 1 on the same set of axes. So x plus 1 will be, it's a slope of 1, right? So it passes through like this, right? So this will be the function g of x equal to x plus 1. Vertical intercept of 0, 1 and a slope of 1. Okay. Now, hence estimate the coordinates of the point of intersection of f of x and g of x. So you just on the graph paper. Sorry.
So do I just look at it from
Naked eye? Yes.
Oh, okay.
Yeah. Nothing more than that. Just look at it and just answer. So it'll be, I'm not even able to estimate, but yeah, you got it right. Minus 0.9 maybe.
Yeah, that's I just looked at it and I got the coordinates.
Yeah. Okay. Sure. Let's go around. Any more, Keshav?
Mine is from 6A.
6A was it? Okay, fine. Let's hold for some more time. Question chapter 5. Anything more, guys? A, B, C. Sumer? All okay?
No, sir.
Anyone? I open it up to anyone in chapter 5. Moksh, all okay? All right.
All okay, sir.
Okay, good. Okay. Question 6, chapter 6, Keshav. Which one was yours?
I had a doubt in 14.
6A. I think you messaged also on the group or separately to me. 6A, question 14. X cube minus 3x square, that one?
Yeah.
Okay, this guy has x minus k whole square as a factor. Show that there are two possible values for k. And for each of these two values of k, find the corresponding value for b. Okay, all right. So this is a cubic. A cubic is given to us. X minus k whole square is a factor. So which means this cubic can be written as x minus k times x minus k times a third root. Let's call the third root as I don't know, p or something, or fine, let's call it p. Okay. And I'll know there's b also in the, I know when I say p and b, it sounds similar. Let's call it some other letter, c. Okay, x minus k times x minus k times x minus c. Okay. Now we know the sum of roots, or rather S1, which is the sum of the roots taken one at a time, is k plus c, which is 2k plus c is minus b by a, which is minus of minus 3 by 1, which is 3. Sum of roots taken 2 at a time is k into k plus k into c plus k into c, which is k square plus 2kc. Okay, so that is given to be 9. Okay, now let's use this to simultaneously solve this, right? So I can substitute. So from this, I can, sorry, I made a small mistake, I think, minus b by, so it's minus of minus 3 by 1. That's the first one. The next one is minus 9 by 1 without the sign change. So it's just minus 9, not plus 9, but minus 9 here. Right? You guys recall that, right? Minus b by a, and then the next one without the minus signage. Okay, so which means see, from the first step we infer that c is 3 minus 2k. So let's substitute 3 minus 2k here. So k square plus 2k times 3 minus 2k equal to minus 9. It's a simple quadratic, but let's still finish it, right? So k square plus 6k. If I'm doing some silly mistake, please call out, guys. Minus 9. Let's lift everything to the right side. So 3k square minus 6k minus 9 equal to 0. I can divide by 3 to make it easy. K square minus 2k minus 3 equal to 0. So which factorizes nicely as k minus 3 times k plus 1 equal to 0. And these are your two values for k. So we have solved, we got two values for k as k is equal to 3 and k equal to minus 1. You're with me completely, Keshav?
Yeah, I just forgot to think about the sum and product of roots.
Okay.
Yeah.
All right. Now, from this we can infer a c, and from this also we can infer a c. So from this, the c inferred is 3 minus 2k. So 3 minus 6, which is minus 1. And from this, the c inferred is 3 minus 2k, which is 3 minus minus 2, which is c equal to 5. So this corresponds to this corresponds to this, right? And then find the for each of these two values of k, find the corresponding values for b. Okay, so b is what? The last one,
Plug
right?
in, just plug in K3 or something. Yes.
Yeah. Or we can even use the product of roots, right? So the sum of roots taken 2 at a time, sum of roots taken 3 at a time, sum of roots taken 3 at a time will be nothing but the product of k into c, right? That's the product of roots essentially, which is how much. You just have to be careful about the signage change. You change sign first, and then you don't change and alternate, right? So you have a sign change here. You don't have a sign change, and then you have a sign change here. So this product is minus b by 1. So which means k into c is minus b. So corresponding to this, k into c will be minus, or rather I'll just say b equal to minus k square c. It's clear that way, right? So I think b would be 9 in this case, if I'm not right. And this case, k square minus k square into c, which is minus 5.
So
Yes, mistake.
I'll have to leave now. No.
Oh, yeah. You did mention to me that you're leaving a little earlier. Fine. Do watch the recording, rest of the recording, Sarah.
Yeah, okay.
Okay. So, right. And therefore, now we can write this quadratic as for each of these two values for k, find the corresponding values for b. We did that. Hence, solve f of x equal to 0. We already solved f of x equal to 0 because we are writing it in this form. The solution for f of x equal to 0 will be x equal to k, and that will be a repeated root. So 3 solutions, x equal to k, x equal to k, and x equal to c. So the solutions are depending on k. So it's 3, 3, and -1, or -1, -1, and 5. Now you might think, how come I have 6 solutions for a cubic? This is a different cubic, this is a different cubic, because the coefficients are dependent on b. So depending on what the b is, you're going to have 2 different cubics. For the first cubic, which is this, right? The 3 roots are 3, 3, and -1. And for the second cubic, where b is -5, the 3 roots are -1, -1, and +5. Okay, Keshav, makes sense completely. Amit, you're with me completely? But keep the video on, Amit, even if you don't have doubts. Did you do this fully, Amit?
Yeah.
You didn't have doubts on this one. Okay, Moksh, you got this one as well. Okay.
So I have a doubt. 6A 17.
Okay. Sure. They've just 1 second. For the people who've not asked doubts, Moksh or Amit, any doubts in chapter 6?
No doubts. No.
No doubts. Okay. Which one did you say? 6A 19?
17. It ends at 17.
Okay. Yeah, ignore this for now, guys.
So because it involves an imaginary root, right? Because it's this
Yeah.
plus root 3 by like I. There is I.
Yeah. So this actually is from the complex numbers chapter. So I skimmed through a few problems which won't involve complex numbers. Maybe looking at it, this might involve. So skip this one, Dave. It's okay.
Oh.
Okay. Avya, anything in 6A, B, or C? Or
No, sir.
all Sumer, you're okay as well? Completely?
No, sir, I have a doubt.
Yes, go ahead, please.
So I'm not sure if this is what I've written, but I don't know if this is the correct one. If you can just show me the question. Oh, I have a doubt in 6B part 9. Like question.
6B question 9. A quartic polynomial, that one?
I'm pretty sure, sir, yes.
Is this the one?
Yes, sir, because I think I just forgot like when touches and cuts. Like
Okay, sure. A quartic polynomial y equal to p of x touches the x-axis at -2, 0. So touches means it's a repeated root. So for example, for anything, right? So let's say this is the x-axis, right? And let's say the graph is coming like this, right? Then it's clearly 2 different roots. If it's coming like this, the 2 roots are very, very close. Here the 2 roots are very, very, very close. Here the 2 roots are so close that they are on each other itself. So which means whenever it touches, it means that it's a repeated root. That's what it means, right? So in this question, it touches at -2, 0, which means x plus 2 is a repeated root. So p of x is x plus 2 into x plus 2 into something, right? It cuts the x-axis at 1, 0. Therefore, it's x minus 1. And then nothing else is given, right? So let's say the 4th root is something else. Let's say x minus alpha. Okay.
Isn't it -3?
Which one?
The 4th one, isn't it just -3?
Does it say somewhere?
No, but it says it cuts the y-axis at 0, 12, and shouldn't it 2 into -1 into minus alpha after equal?
Yeah. See, what I meant was at this point, I don't know. So when I first wrote x plus 2, x minus 1, and when I write, there's nothing else which is cutting the x-axis. Therefore, I wrote it x minus alpha, but you might be right. So now the first step I was going to come to was this. We'll put x equal to 0 and try to solve, right? But actually that won't give us, so there's an a here at the front as well, right? So when x is 0, y is 12. So I know this is 2 times -1 times minus alpha. So I don't know alpha yet because I only know that how much does this simplify to 4a alpha on the right hand side equal to 12. So I know that A alpha equal to 3. That's all I know so far. Okay, but I also know another data point that it passes through 2,80. So I can use that. So y equal to a times, when I put x equal to 2, I get 4 times 4 times 1 times 2 minus alpha. That is given to be 80. So 4 4s are 16. So I can write this as, I can divide by 16 and say 5 equal to. So I can say 5 equal to a times 2 minus alpha. And the easiest way is I can divide the two equations. So 3 by 5 equal to alpha by 2 minus alpha. Again, if I'm doing mistake, please stop me, guys. 5 alpha, and therefore alpha is 8 alpha is 6, therefore alpha is 3 by 4. And knowing alpha is 3 by 4, I can substitute here, and then I can infer A is 4, I guess. A is 4 and alpha equal to 3 by 4. Did anyone do it, and can you confirm this is what you guys got?
I
Or-
got 4x inside the bracket. Same thing.
Oh, okay. So basically what he's saying is he wrote it as x plus 2 times x plus 2 times x minus 1. And then this was 4 and this was 3 by 4 like this. So he brought the 4 inside and wrote this last one as 4x minus 3. Is that what you mean, Keshav?
Yeah.
Yeah, both are the same thing. But the root is 3 by 4. Okay, find an expression for fp of x in the factored form. Hence, sketch the graph.
The rest is fine. I just had out in this part.
Rest is fine, right? Just so that we are all on the same page in graphing. So this will be 2 will be a repeated root. So 2 will be a repeated root, that is gracing. And then what is the other root? Minus 1. And then the fourth root is 3 by 4. 3 by 4, which is here, right? Minus 1. Now, since it's the A is a positive quantity, so it will start with a positive infinity. So the fourth order will look something like this in general, right? So fourth order will be something like this, but right now we know that it has to grace through 2, right? Because it's tangential at 2. So the W shape will be something like this. Does it make sense?
Yes, sir. Got it.
Cool. Anything? I thought Keshav, you had one other doubt also, right? Did you chat me with one other question, or was that the one K?
No, the only thing I only had that was that vectors thing just as asked for the
Which we clarified, right?
yeah.
Shifting right and shifting left. Okay, Amit, you're completely good on all of them so far? No doubts at all?
Yeah.
Okay, all right. What happened? Thais left, I think. Sarah had to leave, I know. Thais also left, I'm not sure. Okay, all right. Let's move on to trigonometry then today. Obviously, we have tomorrow also for trigonometry, but let's cover some of the basics in trigonometry. So first thing I wanted to cover was degrees versus radians, right? So the conversion between degrees versus radians. So by default, angle should be measured in radians. So going forward for like higher grades, unless it specifically says degrees, assume angle is given in radian. Okay, so 180 degrees is pi radian, and use that to back convert anything else, right? So therefore pi by 2 would be 90, right? Different fractions of pi. Pi by 3 would mean 60 degrees. Pi by 6 would be 30 degrees. And of course, 2 pi would be 360 degrees, right? And 1.5 pi, 3 pi by 2 would be 1.5 times 180, which is 270 degrees. So you guys should have a mental mapping. So pi is 180 and work off of that, relatively going up or going down. Okay, what is the meaning of a radian really? So radian is, so you have a circle, right? Right? How much you have to cover? Okay. Okay, so for any theta, the arc length that you cover here will be r theta. The length of the arc PQ, for example, let's say O is the center. So when I say PQ with an arc over it, that means it's the arc length of PQ. So arc length of PQ is r times theta if theta is measured in radians, which is why it's no surprise if theta is 2 pi, then that means the arc length is the entire circle, and therefore you get r times 2 pi, which is the 2 pi r, the circumference that you get. Similarly, the area of the sector area of OPQ, the sector OPQ is half r square into theta. And again, no surprise, if theta is 2 pi, then you get the full circle. Sorry, question from someone?
Yeah, there I had a problem with my internet connection.
Ah.
Could you just
Yes, Thais.
explain it, what you just did?
Oh, okay. So the r theta, that one? Which one, Thais? I'm sorry.
Yeah, the thing with the triangle or
Okay. Were you there for the degrees to radian conversion?
no.
Oh, okay. So maybe I'll just quickly recap, right? So there are two measures for angle, right? One is degree and one is radians, right? So just like you can measure length in either meters or feet or inches or centimeters, like that, think of an angle can be measured using two different units. Degrees is what you have commonly studied until now. Radians is another measure of angle, and which is the more formal measurement, right? In general, going forward for higher studies, radians is the default argument. When someone says sine 30, they wouldn't mean sine 30 degrees, unless it's a silly mistake. They would mean sine 30 radians, right? Of course, if they say sine 30, it's very tempting to check with them. Anyway, do they mean degrees or radians? But in general, when they say sine alpha, it means alpha is in radians. Now, what is this radian? So like I said, another unit, right? So pi radians corresponds to 180 degrees. So pi is just a number. So approximately 3 radians is 180 degrees, which means 1 radian is roughly around 60 degree, slightly less than 60 degree, right? So the definition of 1 radian is how much do you have to cover along the circle till you're able to travel a distance r. If this is r, then this measurement is 1 radian exactly, because the radius is r, right? In general, for a random theta, the arc length is r times theta. If theta is 1, then the arc length is r times 1, which is the radius length itself. So the measurement of 1 radian is approximately, you can see visually, you can see, right? When you travel around 60 degree or slightly less than 60 degree, actually, the arc length is more or less same as the radius itself. So you should have a feel for what 1 radian is, right? That's what I covered. So arc length is r times theta, and if theta happens to be 2 pi, then which means the arc is the entire circle periphery, which is why it's r times 2 pi, the circumference formula that you know. Similarly, area of the sector, this is called a sector, right? The triangle-like area is called a sector, right? So area of a sector is half into r square into theta, right? Angle does not have any dimensions at all. Angle is unitless. R is a length, and no surprise, half is also a number. Half times r square times theta would be a length getting squared. So the units of it make sense. That's an area, right? Always, it's good to do some dimensional check, right? For example, if someone lied to you that area is half into r into theta instead of r square, you should suspect, right? The answer should be a length square. How can it just be a length? And theta is dimensionless. Angle does not have any dimensions at all. Okay, so anyway, it's not half r theta, it's half r square theta. And I was saying if theta is the full circle, which means theta is 2 pi, then you get your pi r square by putting theta as 2 pi. So this is your pi r square, which is your entire circle area. Okay. Now, Thais, so that's all you missed, nothing much, right? And then,
Okay, thank you.
right? So when we go for basic trigonometry, you should know the sine, cos, and tan. So first, let's review in the first quadrant, right? So very basic stuff. So for a given angle theta here, and for a right angle triangle, then as far as theta is concerned, this is the opposite side, and this is the adjacent side, and this is the hypotenuse. Okay, so let me label this as A, B, and C. Okay, Angle B is your 90 degrees here, right? So basic sine theta, cos theta, tan theta, all of us know, but just to be on the same page very quickly, opposite upon hypotenuse, AB upon AC is sine theta. Cos theta is, as far as theta is concerned, the adjacent side is BC, adjacent over hypotenuse. So it's BC over AC. And then tan is just the ratio of the two, which is opposite over adjacent, which is AB over BC. Okay, and the reciprocals of them, reciprocals of each of them, the reciprocal of sine is cosec theta, which is 1 over sine theta, and 1 over cos theta is sec theta, and 1 over tan theta is cot theta. Okay, and basic angles like 0, 30, 45, 60, and 90, all of us should know very well, right? And everything else in, as you go to second, third, fourth, and fourth quadrants will be some version of the angles in the first quadrant. So knowing your angles in the first quadrant is very important. So sine of, again, I'm still operating in degrees. So just to be very clear, I've not shifted to radians, right? But if it's in radians, it'll be 0, 0. This will be pi by 6. This will be 1/4 of 180 degrees, therefore pi by 4, 1/3 of 180, and 1/2 of 180 in radians. Degrees. So sine 0 is 0 and sine 90 is 1. And that you can imagine, right? If the angle collapses to 0, the opposite side goes to 0. So the ratio of the opposite to hypotenuse is 0 effectively. On the other hand, if it's a very steep angle like 89 degrees, the opposite side is roughly same as the hypotenuse. So sine 90 is 1. Sine 30 is half. And sine 60 is √3/2. Okay, and we can quickly derive these. Maybe I'll just take a minute to derive these also, right? Okay, so suppose I have a simple 30 degrees angle here. Okay, so let's say this is 30. Okay, now I can symmetrically draw another 30 degrees below. Just change around the color. So I can symmetrically draw another 30 degrees below. Now this will help me evaluate all of these. So if I draw 30 here, so effectively this has become a 60, 60, and 60, which is an equilateral triangle. Okay, so let's say in the original triangle, let's say the side length was small a, right? And therefore, because of symmetry, this was also small a. Okay, now this whole thing, this whole big triangle, A, B, C, is an equilateral triangle. Therefore, if the side length is 2a here, it has to be 2a everywhere. So this has to be 2a. This also has to be 2a. Right? Now we can focus on the small triangle and say, if this is a, opposite is a, and the hypotenuse is 2a, sine 30 is a upon 2a, which is how you get sine 30 is half. Right? And just by using Pythagoras theorem, I can calculate this guy is square root of 2a whole square, sorry, 2a whole square minus a whole square, right? Which is square root of 3a square, which is √3 times a, or a √3. So this was a √3. Okay. Therefore, the adjacent side is in this triangle I meant is a √3, and the opposite side is a, and the hypotenuse is 2a. Therefore, cos 30 would be √3/2. Cos 30 would be √3/2. So I wish I had more space here. So let's say cos theta here. So cos and sine will be complementary, right? So cos 0 is same as sine 90 and vice versa. So cos 60 is your half and cos 30 is your √3/2, as we just saw. Cos 30 is √3/2. And then at 45, both will be same. Will be 1/√2 and 1/√2. And that also you can easily prove, because if I take a small 45, 45, 90 triangle, it's an isosceles triangle and right angle. Therefore, this is 45 and this is 45. Because it's isosceles, let's say this length is x, this length is also x. Therefore, this becomes square root of x square plus x square, which is square root of 2x square, which is x root 2. And therefore, opposite upon hypotenuse becomes 1 over root 2. Same thing with adjacent upon hypotenuse. So this is also 1 over root 2. And then tan is just the ratio of the two. Sorry, you have to delete this. So tan is just the ratio of these. So tan 0 is 0. Here it's 1 by root 3. Here it's 1 by root 2 by 1 by root 2, which is 1. Here it's root 3. And here, some people write infinity. It is wrong. It's not infinity. It's not defined. Not because 1 by 0 and all that, but because slightly to the left of 90, tan theta will go to positive infinity. Slightly to the right of 90, tan theta will go to negative infinity. So the 90-degree point or the pi by 2 point will be a vertical asymptote for the graph tan theta. So tan will blow up to positive infinity, close to 89.99 degrees, and it will blow down to negative infinity when it's 90.001 degrees. Okay. Right. Now, so basic sine, cos, tan we have covered. And now how do we tackle with angles which are more than 90? Okay, so that's important. Actually, before that, we should do sine of a plus b and all that, right? That recap. So when I add angles, what happens to sine of a plus b? So sine of a plus b is sine a cos b. I'm just writing s for short, plus cos a sine b. Okay, so for example, we can use this to find sine 45 degree, sine of 30 plus, not 45, I meant 75, because we know 30, we also know 45, but we don't know 75, but we can use this to find sine 75, for example. Okay, similarly, sine of a minus b will be sine a cos b minus cos a sine b. So in the same formula, I can write two formulas. Sine of a minus b is sine a cos b minus cos a sine b. Okay. Similarly, if I have cos of a plus b, it's cos a cos b minus sin a sin b. So it's reverse. And cos of a minus b is cos a cos b plus sin a sin b. Okay, and let's do some basic check. So for example, we know sine 0 is 0. Do we get that? So if I put b is b and a are same, then sine of a minus a would be sine a cos a minus cos a sine a, which is as expected 0. Right? Similarly, we expect cos 0 to be 1. Do we get that? If we keep a and b as both same and we do cos of a minus a, it's cos a plus sine a sine a, cos square a plus sine square a, which we know is 1. Right? So we are able to validate that sine 0 and cos 0 are 1. By the way, why is cos square theta plus sine square theta equal to 1? Let's do that also. So in a small right angle triangle, so let's draw a small right angle triangle again. Okay.
So what is the small s? Like when you say s, capital A.
Oh, sorry. That's just me being lazy. Sine A, cos B.
Okay, cos B.
A, sine B. You wouldn't see this in textbooks. It's just me being lazy. That's it. Right? Sine A cos B plus cos A sine. Okay. Right. So if I have a small right angle triangle here, let's say this side length is x, this side length is y, and the hypotenuse is z. So we know x square plus y square equal to z square. And let's say this is your theta, right? Right? Now, if I divide throughout by z square, I get x square by z square plus y square by z square equal to 1. And that's what your cos theta whole square is. X by z is nothing but sine theta, sorry. Maybe I should have put x and y in the reverse direction, right? X is always horizontal, y is vertical. So let me do that. So x is here, y is here. So x by z is your cos theta. So this is cos square theta. By the way, cos square theta is same as cos theta whole square. Huh? Okay. And this is not same as cos of theta square. You can technically think of the angle itself getting squared and then doing cos of that. but it's not that. It's cos theta whole square. Okay. So here we get x by z, which is cos theta. Similarly, y by z, which is sine theta. So that's how we get cos square theta plus sine square theta equal to 1. Now, from the same equation, rather than divide throughout by z square, I can divide throughout by x square. So I get x square by x square plus y square by x square equal to z square by x square. So this is 1. Y by x is tan theta. Therefore, 1 plus tan square theta is, what is z by x? Z by x is the reciprocal of x by z. X by z is cos theta, right? Z by x is the reciprocal of cos theta, which is sec theta. So which is how you get 1 plus tan square theta is sec square theta. Similarly, I can take this equation and divide throughout by the third one, which is y square. So I get x square by y square plus y square by y square, which is 1, equal to z square by y square. So here we get another relation, 1 plus, I'll write 1 plus first. X by y is the reciprocal of y by x. Y by x was tan theta. X by y is cot theta. So 1 plus cot square theta. Now, what is z by y? Reciprocal of y by z. Y by z was my sine theta. Reciprocal of that is cosec theta. Okay. Again, all of this stuff you guys would have already done in 10th grade. Just a more recap, right? So 1 plus cot square theta is cosec square theta. Thais, all good so far? Have you even done all this, right, in 10th grade? Right? More like a quick recap at this point. Okay. All right. So these are the three basic ones, cos square plus sin square and all that. Now, using this sine of a plus b, you can also infer what is sine of a plus a, just sine of 2a. So sine of 2a will be sine a cos a plus cos a sine a, which is nothing but sine a cos a plus cos a sine a is 2 times sine a cos a. So sine 2 theta is 2 sine theta cos theta. Similarly, cos of a plus a is what? Okay, fine. It's too boring to do just a. I'll just switch to theta or something, right? So cos of theta plus theta is, according to this formula, is cos theta minus sine theta sine theta. So it's cos square theta minus sine square theta. So cos 2 theta, this is cos 2 theta. It's cos square theta minus sine square theta. Now I can write it in a couple of different variations also. I can replace cos square theta as 1 minus sine square theta. Therefore, I can write 1 minus sine square minus sine square. So it's 1 minus 2 sine square theta. On the other hand, I could replace the sine square theta as 1 minus cos square theta. So it becomes cos square minus, within brackets, 1 minus cos square. So it will become 2 cos square theta minus 1. So all of these are important, right? So depending on the situation, you would use one of the three for cos 2 theta, right? And again, I can rewrite this in a different way also. So for example, this one, I can write 1 minus cos 2 theta by 2 is sine square theta, right? Just rearranging. This is cos 2 theta. This is also cos 2 theta. So just rearranging, it's 1 minus cos 2 theta by 2 is sine square theta. Similarly, here it will become 1 plus cos 2 theta by 2 equal to sine square theta, is equal to cos square theta, I'm sorry. Okay. And then lastly, we'll do tan of a plus b and tan of a minus b. So tan of a plus b first would be tan a plus tan b. Again, me being lazy, upon 1 minus tan A tan B. Okay, and if it's minus, the plus and minus get swapped. So tan of A minus B is tan A minus tan B upon 1 plus tan A tan B. Okay, and we can use this, for example, to find what is tan of 22.5 degree, or tan of 22.5 is what? Let's practice with radians. 1/2 of 45. 45 itself was pi by 4. So I can use this to find tan of pi by 8. Right? So tan of pi by 8 plus pi by 8, which is tan of pi by 4. Tan of 45 degrees, which we already know is 1. Right? But we also know by this formula. So let's say tan pi by 8, I'll just call it as some x or something, right? That's what I'm trying to find out. So tan pi by 8 plus tan pi by 8 upon 1 minus tan pi by 8 times tan pi by 8. So I can use this to find my tan pi by 8 easily. So if I just do this quadratic, I get 1 equal to 2x by 1 minus x square. So 2x equal to 1 minus x square plus 2x minus 1 equal to 0. So I'll solve this using minus b plus or minus root of b square. B square is 4, sorry, minus b is minus 2. B square minus 4ac will become plus 4 whole upon 2a, which is minus 2 plus or minus root 8, which is 2 root 2 upon 2, which is, I can divide by 2, minus 1 plus or minus root 2. But we know tan of 22.5 degree or tan of pi by 8 is positive. Therefore, it has to be minus 1 plus root 2. Right? That's your tan 22.5 degrees. So I can use this to figure out some angles like this. Right? There are other techniques to find for 18 degrees, for 36 degrees. Using, yes, go ahead.
Basically you're working in reverse. You are taking the tan pi by 8 as x.
Correct.
And you're saying that if you're performing a certain operation on x, you get tan pi by 4 and then working in reverse.
Exactly.
So the other root of the quadratic, namely minus 1 minus root 2, that would give you the other value of tan theta equals 1, which would be I believe 9 pi by 8. And so this, the other root minus 1 minus root 2 is like the corresponding other tan value. That makes sense, right?
You're almost right. One very small mistake you did. Yes. So what is this other root telling you? So there are two values for theta when tan theta is 1. So tan theta is 1 when theta is 45 degrees or pi by 4 radians. That's the first quadrant. And then we'll do it in next class in more thorough fashion.
What was the tan
225 degrees, which is 5 pi by 4, right? So the other angle that you're seeking is 5 pi by 8.
Yeah. My mistake.
Yeah. So tan of pi by 8 was this. Again, if you guys didn't follow, it's fine. Others didn't follow. Tan of 5 pi by 8 would be this minus 1 minus root 2. Yeah. Okay. All right. So with this, we'll stop. So far, nothing. Maybe.
Sir, doubt.
Yes.
So why is it equal to 1 plus root 2 is equal to tan 22.5, not tan 45? So,
Tan 45 is 1. That's what we started off with.
okay.
So, okay, let me just, maybe I did it quickly, right? So instead of replacing, by replacing A and B with both alpha and alpha, we said tan 2 alpha is tan alpha plus tan alpha, which is 2 tan alpha, by 1 minus tan alpha, which is tan square alpha. Correct? You're with me so far? Now, if I put alpha is pi by 8, so I get this. Pi by 8 is my 22.5 degrees. This is tan of 2 times alpha, which is tan pi by 4, which we know is 1. So using tan pi by, so you're using tan of 2 alpha to find tan of alpha. So it's not always that, what I'm trying to illustrate is, it's not always the lower angle is known and the double angle is unknown. Sometimes it could be the double angle is known, 45 degrees is known, but 22.5 degrees is not known. I can use it to find. Okay, all right, let's stop here. I think this is pretty much what you guys already know anyway. And then we'll go into operating in the second, third, fourth quadrants and other stuff next class, tomorrow, that is. Okay, now that we have thoroughly discussed the functions homework. All right, see you tomorrow. Bye.
That's